Hello everyone. In this video, we are going to discuss about the trigonometric identities. We are going to prove these trigonometric identities given here. See, so far we have discussed about the 8 trigonometric identities which are available in the playlist. Now this is the 9th one. In the 9th one, we have actually 8 trigonometric identities together given as the 9th one. So you see, first I am going to prove the first one. That is, I am going to prove cos of pi by 2 plus x is equal to minus sin x. This is a trigonometric identity. Cos of pi by 2 plus x is equal to minus sin x. So let us see how to prove this. So you see, when we have discussed about the third trigonometric identity in our previous video, the third trigonometric identity was actually cos of x plus y equals cos x into cos y minus sin x into sin y. Okay, so I am going to use this third trigonometric identity here to prove this. So here what I am doing is, I am going to replace this x by pi by 2 and y by x. So this third trigonometric identity will become cos of x is replaced by pi by 2. So pi by 2 plus y is replaced by x. So cos of pi by 2 plus x is equal to cos x, that is cos pi by 2, into cos y, that is cos x, minus sin x, x is pi by 2, into sin y. So y is x, sin x. So this can be written as cos of pi by 2 plus x is equal to cos 90, 0, cos pi by 2 0. 0 into cos x will be 0. So 0 minus, so minus sin pi by 2 is 1. 1 into sin x is sin x. Okay, so you see cos of pi by 2 plus x is equal to minus sin x. We have proved that. Now let us see the proof of the second one. Cos of pi minus x is equal to minus cos x. So now we are going to prove this trigonometric identity, that is cos of pi minus x is equal to minus cos x. So you see, to prove this, I am going to use the fourth trigonometric identity which I have discussed in our previous video. That is, the fourth trigonometric identity was cos of x minus y equals cos x cos y plus sin x sin y. This was actually the fourth trigonometric identity. So I am using this trigonometric identity to prove this, to get this one. So you see, what I am doing is, I am going to replace this x by pi and I am going to replace this y by x. So this becomes cos of x minus y. X is pi minus y is x equals cos x is pi cos y is x plus sin x is pi y is x. Okay, so this becomes cos of pi minus x is equal to, this is cos pi, its value is minus 1, minus 1 into cos x is minus cos x. Sin pi, its value is 0, 0 into sin x is 0. So you see, this will be cos of pi minus x is equal to minus cos x. Okay. Now let us prove the third one, which is sin of pi by 2 plus x is equal to cos x. So to prove this identity, what I am doing is, I am going to consider the seventh identity which we have already discussed in our previous video, which was actually sin of x plus y equals sin x cos y plus cos x sin y. Okay, sin of x plus y is equal to sin x cos y plus cos x sin y. So by using this seventh trigonometric identity, I am going to prove this one. So here what I am doing is, I am going to replace this x by pi by 2 and this y by x. So the seventh trigonometric identity will become sin of x plus y, that is pi by 2 plus x is equal to sin x, x is pi by 2, cos y, y is x, plus cos x, x is pi by 2, sin y, y is x. Okay, so this actually becomes sin of pi by 2 plus x is equal to sin pi by 2 1, cos pi by 2 0. So 0 into sin x will be 0. So second term becomes 0. This is 1 into cos x. 1 into cos x is cos x. So this is proved. Now let us prove the fourth one, which is sine of pi minus x is equal to sine x. So to prove this trigonometric identity, I am going to consider the eighth trigonometric identity which we have discussed in our previous video, which is sine of x minus y is equal to sin x cos y minus cos x sin y. And what I am doing is I am going to replace this x by pi and y by x in this eighth trigonometric identity. So this eighth trigonometric identity, this will become sin of x minus y, that is pi minus x, is equal to sin x, x is pi, cos y, y is x, minus cos x, x is pi, sin y, y is x. Okay, so this will become sin pi is actually 0, 0 into cos x is 0. Then minus cos pi is minus 1. So minus 1 into minus, that is plus 1 into sin x, sin x. Okay, so this one is proved. Sin of pi minus x is equal to sin x. Next, we are going to prove this identity, which is cos of pi plus x is equal to minus cos x. For that, I am considering the third trigonometric identity, which is cos of x plus y is equal to cos x cos y minus sin x sin y. So, in the third trigonometric identity, I am going to replace this x by pi and this y by x. So, the third trigonometric identity becomes cos of x plus y, that is pi plus x, equals cos x, that is cos pi, into cos y, that is cos x, minus sin x, x is pi, into sin y, y is x. Okay, that is we can write cos of pi plus x is equal to, see cos pi, it is minus 1, minus 1 into cos x is minus cos x, sin pi is 0, 0 into sin x is 0, so second term becomes 0. So you see cos of pi plus x is equal to minus cos x. Next, we are going to prove this trigonometric identity, which is cos of 2 pi minus x is equal to cos x. So for that, I am going to consider the fourth trigonometric identity, which is cos of x minus y is equal to cos x cos y plus sin x sin y. And in the fourth trigonometric identity, what I am doing is I am just going to replace this x by 2 pi and this y by x. So the fourth trigonometric identity expression becomes cos of 2 pi minus x equals cos x, that is cos 2 pi, into cos y, that is cos x, plus sin x, that is sin 2 pi, into sin y, which is sin x. Okay, so see sin 2 pi, which is equal to 0, so second term becomes 0. Cos 2 pi, which is equal to 1. So first term becomes 1 into cos x is cos x. So cos of 2 pi minus x is equal to cos x. Hence we proved this. Now next let us prove this trigonometric identity, which is sin of pi plus x is equal to minus sin x. To prove this, I am going to consider the seventh trigonometric identity, which is sin of x plus y equals sin x cos y plus cos x sin y. And what I am going to do is, in the seventh trigonometric identity, I am going to replace this x by pi and this y by x. So the seventh trigonometric identity becomes sin of x plus y, that is pi plus x, equals sin x, x is pi, so sin pi, cos y, y is x, so cos x, plus cos x, that is cos pi, into sin y, that is sin x. Okay, now you see this sin pi, this is actually equal to 0. So 0 into cos x, 0. Cos pi, which is equal to minus 1. So minus 1 into sin x is minus sin x. So you see sin of pi plus x is equal to minus sin x. Next, we are going to discuss this trigonometric identity, which is sin of 2 pi minus x is equal to minus sin x. To prove this, I am going to consider the eighth trigonometric identity, which is sin of x minus y is equal to sin x cos y minus cos x sin y. In the eighth trigonometric identity, I am going to replace this x by 2 pi and this y by x. So this becomes sin of x minus y, that is 2 pi minus x, is equal to sin x, that is sin 2 pi, into cos y, that is cos x, minus cos x, that is cos 2 pi, into sin y, that is sin x. Okay, now you see sin 2 pi 0, 0 into cos x will be equal to 0. And cos 2 pi, which is equal to 1. So this becomes sin of 2 pi minus x is equal to, first term 0, second term minus cos 2 pi is 1. So minus 1 into sin x, which is minus sin x. Okay. So in our previous videos, we have discussed about the first 8 trigonometric identities. In this video, we have discussed about the ninth one, in which we have 4 plus 4, 8 trigonometric identities. I hope it is clear to you. Thank you.